Hey guys, so in class we've been talking about proportional relationships, everything having to do with proportions, but we haven't really got to talk about non-proportional too much. So this whole lesson is going to be non-proportional relationships, linear non-proportional relationships to be specific. Also, when this is my blue sheet to cover up the answers, okay? What's highlighted is what's going to go in your blanks, alright? So this first one. Remember, a proportional relationship has to do two things. It has to go through the origin, and it has to have a constant rate. Remember, constant with the k, so y is equal to, nope, I lied. K is equal to y divided by x. That has to be the same for everything. Alright? Also, a linear equation, that's a new word. Linear equation just means an equation that's with a line. It's written in the form of y is equal to mx plus b. We've kind of seen something like that, but we're adding a new element. We're adding this plus b part. Alright? When b, remember this means not equal to, so when b is not equal to 0, it is a non-proportional relationship because it will not go through the origin. Remember, it has to go through the origin in order for it to be a proportional relationship. It will still have a constant rate though, and it still will be a straight line. So, how do we represent linear relationship using tables? Well, when you're filling out a table and you have a formula, okay, so when it gives you a table and it gives you a formula as well, all you need to do is substitute each x value into your equation and solve for y. I know that sounds confusing, it's really not. We're going to do examples later. This is your equation that you're going to get. Okay, y is equal to mx plus b. We just talked about it. M is going to represent your slope or your constant rate. Okay, and then this plus b part, this is now what this is going to call our y-intercept. All that means is where line crosses y-axis. Alright? Here's a huge tip and hint. If your table does not give you 0 as an x value, you need to expand your table and add a 0 value. Basically, if you ever see a table that does not have a 0 value for x, you need to add it. Alright, enough with notes. Let's do some examples because I feel like that's how y'all learn best. Francisco makes $12 per hour doing part-time work on Saturdays. He spends $4 on transportation to and from work. The equation y is equal to 12x minus 4 gives his earnings y, so y represents earnings, after transportation costs for working x hours, so x is our hours. Make a table of values for this situation. Now, I don't care what you do. I don't care the number of hours. You're going to start with your x's, so we want to figure out x's. I don't care what you do, but we did say that up here we always want 0 as one of our x values. So I'm going to start with 0. If he works 0 hours, how do you solve for y then? Well, that's simple. We have an equation right here. You have an x value. We can figure out a y value. So you substitute. Y is equal to 12. What does x represent? Right now, x represents 0 minus 4. Now you use jumps to solve. Y is equal to 12 times 0 is 0 minus 4. Y is equal to negative 4. So if he works 0 hours, he's actually losing money. He loses money because we have to, this $4, he's still spending $4 on transportation even if he works 0 hours. Alright, and let's do 1 and then 3 hours and then 5 hours. Now I want you to try and see if you can solve for y for 1, 3, and 5. Pause it and see if you can do it. Okay, so you should have come back. You should have had y is equal to 12 times 1 minus 4. Y is equal to 12 times 3 minus 4. And y is equal to 12 times 5 minus 4. Now if you solved, you would get y is equal to 12 minus 4, y is equal to 8. So if he works 1 hour, he will still make $8. if he works 3 hours, he'll make $32. And if he works 5 hours, how many dollars will he make? 56. Guys, all I did was use this equation right here. I made up my own x values. Could you have picked any x value? Yes, any positive x value, because number of hours has to be a positive number. Okay, and all I did was plug x, the number of hours, what I was picking, into the equation to figure out how many dollars he earned. Alright, pretty simple, huh? Well, let's go on to example number 2. It says, make a table and graph the solutions of the equation y is equal to negative 2x plus 1. Alright, well, we have a table that we need to fill out. Alright, it does give us our x value, so we're good there. We do not have to expand the table. All that means is if it didn't give us an x value, we'd add an extra box over here, and we make one 0. But we already have that, so we do not have to expand. So, y is equal to negative 2 plus 1. To figure out what this is right here, what should I plug into my equation to figure out what y is? I don't know y. Good. This is associated with negative 1, so you plug it in. Negative 2 times negative 1 is positive 2 plus 1 is y is equal to 3. So, when x is negative 1, y is 3. Alright? We'll figure out what 0 is. When y is 0, when x is 0, y is positive 1. All I'm doing is solving. You can pause this and do it yourself and check if you want. When x is 1, y is negative 1. And last but not least, when x is 2, y is negative 3. Okay, the second part of the equation question says to graph it. Well, let's graph. Here, your first coordinate is negative 1, 3. This is your x, this is your y. X, we go negative 1. Then you go up 3. 1, 2, 3. Now, when x is 0, remember, that means where is it going to cross the y-axis? Where is it going to cross the y-axis? Because see, we go over 0 and we go up 1. So look, do you see your plus 1? It's talking about this right here. It's saying we went up 1. Alright, that's your y-intercept. This is your y-intercept. That's where it crosses at positive 1. Alright, we go, this third point, we go over 1, down 1. Then we go over 2, down 1, 2, 3. Now, I don't have a ruler. Y'all probably don't either, so just make the line the best you can. Alright, we drew a line. Now, is this proportional or non-proportional? You should have said non-proportional because it's not going to go through 0. And this whole lesson is about non-proportional. Alright, flip over. Nope, I have nothing on the back there. Alright, we flipped over. Now, what does it say? There are a few quote-unquote special equations that would be helpful for you to memorize. I'm giving you this hint because we're doing an activity and you need to know these special equations. So let's look. When x is equal to any number, so for this instance 3, when x is equal to 3, it means all of your x values are going to be 3. So x values go over, so over 3, up 1, over 3, up 2, over 3, up 3, over 3, down 1, over 3, down 2, okay? So when x is equal to any number, it's just going to be a straight up and down line. Will always go up and down. Alright? When y is equal to x, when you have an equation like this, you want to pretend that there's a 1 in front of your x. Remember, 1 is your rise over run, right? Pretend there's a 1 in front of x. So what that means is If your rise over run is 1 over 1, right, because we can rewrite that as a fraction, start at the origin, up 1 over 1, up 1 over 1, up 1 over 1. Down 1 over 1, down 1 over 1, okay? Because once you do one way, you have to do the opposite way as well. Connect your line. We're looking good. This is a always positive slope. Alright, let's look at this one. When y is equal to any number, it means all your values are going to be y is equal to whatever your number is. So, you go over 0, up 1, 2, 3. Over 1, up 1, 2, 3. Over 2, up 1, 2, 3. Over 1, up 3. Okay, so your y values are always going to be 3, so it's always going to look horizontal. Remember, this is 0 slope. Okay, always go right and left. All y values 3. Alright, let's look at this. This one right here. Oh. This positive 2 right here, this positive 2 is called your what? Good, it's called your y-intercept. So that means it's going to cross at a positive 2. So that's where you put your first point. Remember, when there's nothing in front of the x, we pretend that there's a 1, 1 over 1. So your rise over run is up 1 over 1, up 1 over 1, up 1 over 1, down 1 over 1, down 1 over 1, okay? That's called your slope. That tells you how steep it is. It's also rise over run. It's kind of like an understood 1, right? Because it cancels out. It's not really that important, but it definitely helps you. So when there's nothing in front of your x, always would think of it as if there's a 1 in front of your x. Alright? Y-intercept is equal to 2. It's a positive 2. Alright, what happens if there's a negative x? Well, let's figure out where it crosses first. It crosses at positive 2, so it still crosses right here. But it's a negative x, so that means there's going to be a negative 1 or negative 1 over negative 1 over 1. So that means it's going to go down 1 because the negative 1 says down 1, then over a positive 1, down 1, over a positive 1. What you do one way, you have to do the other though. So up 1, negative, up 1, back. This negative means there will be a negative slope. Remember, this kind of looks like an N. Alright, and it still crosses at a positive 2. Your y-intercept is still 2. Last one that you should memorize. This minus 3 means it's going to cross at a negative 3. So 1, 2, negative 3. There's a negative sign in front of our x, which means the slope is negative 1 or negative 1 over 1. So we still go down 1 over 1, down 1 over 1, up 1 over 1, up 1 over 1. Do you still see how you still have a negative slope? Okay, so we just graphed all those lines. Okay, that's important for you to know. Look at these, try and memorize them best you can. Use the helpful hint. Don't forget, this means negative. And it crosses at negative 3. Have a great night. Don't forget to answer your Google Doc. Bye.